probably approximately the size of great white today, but this is contemporary with the Pennsylvania fossils of 320 million years ago. And these were found, these fossils come from the Mazon Creek Formation, Kankakee, Braidwood, Joliet. I don't know precisely where these fossils come from, but I know that these are index fossils of those areas, and these are representative of Mazon Creek fossils.
Do they still dig up this stuff? They just don't?
Yes, the quarries are active, and if you drive Interstate 39, you'll go between Ottawa, LaSalle, Peru, and you'll see quarries, active quarries in that region. So yeah, it's quarried in Illinois, Indiana.
Where was it at?
I don't think there's any in Iowa that I know of. That doesn't mean there aren't. But these are representative of the Paleozoic environments that you can discover in Illinois, in the state of Illinois.
That's cool.
And most of these, well, the Mazon Creek fossils aren't as easy to walk up and find. The convenience is there was coal mining around Braidwood and Kankakee, and particularly in an area around Braidwood, a gigantic coal mining operation dug down through the layers, and they put them on, they put the debris on long conveyors, and they just ran it out and poured it on the landscape. So instead of having to find the layers, they conveniently dug down to the coal, removed the coal, and dug down through more layers and deposited on the landscape. Today, in an aerial photograph of that very region around Braidwood, you'll see these concentric ridges of this material. They just moved the conveyor and then moved it in or out. I don't know which. And now the coal mines closed in the 1970s, 1980s, and that's now a reclaimed recreation area, Mazonia Braidwood State Recreation Area. And if you're familiar with driving north on I-55, you go right past the Braidwood Nuclear Power Plant. And this recreation area is just south of the power plant. As a matter of fact, the north boundary of that recreation area is the south boundary of the nuclear power plant.
Is that located south of Chicago?
Yes.
Okay.
50 miles.
50 miles or so, about an hour before Chicago. I didn't never know. I took that highway hundreds of times and never knew it was a nuclear power factory
they
off the highway.
As a kid, I thought they looked like drums because they were round.
Oh, okay, yeah,
And,
yeah.
They change the color every few years.
So they might be close to like the windmill harvesting, the windmills that's up there on off of 55 north.
I'm not
No, it's
Familiar.
farther north.
It's farther north than the windmills.
Yeah.
Okay.
Yeah, most of the wind turbines are in central Illinois.
Oh,
Yeah.
central Illinois, not as far
Yeah.
north. Okay. Okay. It's,
Where the landscape is more glacial and we have rolling landscape, so the wind turbines can sit right in the weather.
yeah, makes sense.
And the wind.
Yeah. So you're saying these fossils they came from an ocean? These was ocean fossils?
These are terrestrial plant fossils. These are marine environment, from a marine environment. And this was a period 355 million years to almost 300 million years, so.
That it was marine life.
Well.
In
it was
Illinois.
Transitioning.
Transitioning.
As the continents were moving.
Okay,
They were kind of bumping up and down
the
and
plates.
doing this.
Yeah.
And this was a time where what we are standing on now was closer to the equator.
Yeah.
And there were coastlines, and at this time, if you investigate fossils of 320 million plus or minus 5 million either way, you'll find a variation in the environments across the surface of Illinois.
Interesting.
Southern Illinois is marine fossils.
That's what I was just talking to her about, is that we was at the Shawnee National Park, and I was hiking through the bottom of the Shawnee National Park, and I seen some coral reefs and everything, and I said, wow, this kind of looks like we're in the bottom of an ocean, and it was humid like it was in the bottom of the ocean. And then I read a plaque that said, 300 million years ago or so, that the Shawnee National Park used to be an ocean.
Yes.
And so I was just wondering, how far did that ocean encompass as far as like when it comes to Illinois?
It moved back and forth, and this display is an example of what geologists call a cyclothem.
Mm-hmm.
And the cyclothem is that whole chunk.
Yeah.
And that means the environment was changing from, where is it? Coal represents living plants, and the carbon that was derived from plant tissues. And the sea levels started to rise because of melting ice caps or continental plates being pushed up and pushed down. So this is a shallow marine environment. This is like a coral reef.
Yeah.
This is a warm, shallower marine environment. And this would be an abyssal of a deep ocean environment with less marine life. And then the ocean started to go down because plates were moving, ice caps were forming, withholding the water.
Yeah.
So you reverse that cycle and you return to a terrestrial environment with the next layer of coal. So
wow.
This represents, they call it bouncing landscapes, but it was over millions of years.
Yeah.
And so it was imperceptible to life at the time, but
that's interesting.
You see different fossils adapting and transitioning. So as you move up and down,
yeah, that's pretty interesting.
Different types of life.
So don't they say about every 10,000 years it's an ice age or so?
Thank you for coming.
Oh, you bet. That's very interesting.
Roughly. The 10,000 years, it's actually more like 11,000.
Okay.
It's called the Milankovitch cycle, which the Earth wobbles on its axis as it rotates.
Yeah.
So the Earth wobbles on its axis over a period of 11,000 years. And so as it's going around the sun, it changes slightly the seasons. So over an 11,000 year cycle, you can have warmer or cooler seasons. And that may or may not transition to ice ages.
Okay.
Ice ages are a combination of things. The Milankovitch cycle contributes greatly, but also where the continents are, whether you've had inputs of burning with smoke.
Yeah.
Volcanic
Yeah.
activity, volcanic gases, and humans.
And humans, yeah.